communication. Computation in the sense like now you have some data that is in plain text, then running any algorithm on that is quite easy. Like if you know the algorithm and then like how you can use it for some purpose, then you can run it without any hazard. Like, but the challenge will be if the data is in plain text mode, then it will be available to everyone to access it and then do some modification or whatever. But the challenge there lies if the data is sensitive in nature, and then like if you can get sensitive information from that. Sorry?
I
Sir?
think your voice is echoing.
Okay. One second.
Or is it from your end or from any other participant side?
I'm not understanding. Like now also is it echoing?
No, now it is clear.
Okay. Yeah. Okay. So please do let me know, sir. Like if it is echoing now also.
No, now it is clear.
Okay, so from the data point perspective, like we will see how the security matters a lot in the present day communication and then computation. So computation is also quite important because the data that is there in the device or at the cloud, like see if it is only for the intended users, that is fine. But if it is stored with if it is shared or the people who are not allowed to access or accessing the data, that time the problem will start. So now in that aspect, like what we can do, like due to the large number of online transactions that are happening and everywhere this online mechanism is there, including this FDP, like lot of content is been generated. In such aspects, like how we can take care of the security aspects in particular, we will see. And also like one of the studies, we will take the health wise data or the health sector data, and we will see how that health sector data we can maintain the privacy preserving computation and then the communication as a case study, and then we will discuss the other aspects that do exist in this case. When we say about the privacy preserving computation, like the first thing we may or everyone knows that like security comes with a lot of cryptographical algorithms with encryption and decryption that can be even like public key crypto system or the private key crypto system. In the case of the public key crypto system, like the sender will use the public key of the receiver and then encrypt the message and transfer it over the channel, and the receiver will use his private key and then he will decrypt the message. Similarly, in the case of a private key crypto system, it do happen that the sender will encrypt using the private key and the receiver will decrypt it using the private key. That is what the private key crypto system is. Now, the challenge here is if the data is encrypted and transmitted, that is fine, and the receiver will decrypt it. But if you are storing the data in a third-party server or at a place which has been accessed by many people, in that case, like we need to take care how this privacy matters. Like for example, if you take cloud, multiple people store the data over the cloud. Like if it is a heterogeneous cloud, right? And then they can try to access our data, and then they can get meaningful content of the data, even though they are not intended to. So even in some sense, like you can say that storing the data on the cloud is not secure. That is one aspect, and the other aspect is if the cloud itself, if it can be dishonest, then it can change the content of our data. Then you can imagine like where to store the data in such application. It need not be on a server or a cloud. Like even if you take a standalone server in your premise, wherein you will store your student grades, and over a period of time, if you want to access the data, like if something is been modified there, then we will not be in a position to understand what has happened. So in such cases, like what we can do. So in the today's talk, we will have like this is the content I am having. The overview of the talk will be like first we'll start with an introduction, and then like what are the scenarios that do exist in the private computation or the data, and then what are the models of predictive analytics that do exist in healthcare, and then we will see practical homomorphic encryption scheme briefly and see what are the challenges that do exist in this space, and then we will proceed to the conclusion. So this part will have two parts. One is the privacy preserving computation, and the other part will be the privacy preserving communication. Both are relevant in the present day scenario with a lot of data that has been there. Yeah, like with a lot of data that has been generated and transmitted over the communication channel, right? That need not whether the data that we are communicating is useful or not. That is the secondary question. But the initial level of security that need to be ensured, so that like some of the challenges in the communication aspects, we have challenges like denial of service attacks or even replay attacks, and all those things can be session attacks can also be mitigated. And in the computation side, we can make sure that no third party person is having access to the data. Like we can say that access control can do that job, but access control is not in a position to take it over. That also we will discuss, and then we will proceed further. So like is the second slide is visible, sir? Just to confirm if the slides are moving, or if the participant, if anyone can come, just confirm that if the slides are moving, it should be helpful. Are you able to, yeah, okay. So I'm on third slide, right? Third slide now. Okay, fine. So, like when large amount of data from different patient relevant to a particular disease is available, then building prospective predictive models from the data using machine learning contributes substantially to medical service and medical good. That is the reason we do the predictive analytics or predictive models we use to train the model and then like get the output from that. But the challenge here is like if we are able to get back to the patient whose data it belongs to, then it is a privacy challenge. Privacy challenge in the sense like now you are having your data, then you may not be comfortable in sharing it with the others with some sensitive information. Like why I'll give you an example. Suppose say you are having a smart meter at your home, right? Now a smart meter in the sense like it will calculate all the energy consumptions which you are making at your home, and it will store it some server, right? That is will be in the plain text. Now if there is an intelligent thief who knows data analytics, so he can try to access what is there in the data, and he can find out a pattern of your behavior. Pattern in the sense like at what time you sleep, at what time you wake up, then like at what time you're out of the house, and like at what time you get up in between if you require something, or like when you're available at home. All that patterns he can make out from the data, and he can use it for some other reason. In that case, you can imagine if that data is stored on some third-party server or third-party cloud, without your knowledge, you are being monitored passively. So you can imagine what kind of challenges that can lead to. This is one way. And the other way is like if someone can automate these tasks, and then the cloud itself can read from the content of the data which is in plain format. And if it provides analytics to the unauthorized users, you can imagine what kind of how to say panic situation it creates, right? Like see, these are all the things which we may not do it wantedly, but unknowingly we may do it, right? So they're like without a piece of some information leakage, no one can have access to any of the security aspects, right? Okay, but having said this, like do we need to detail or like have refrain from doing this, that use smart meters or like keep the data on the cloud and all? No, that is not possible. We have to do it for the medical good or whatever may be the reason is. Like it is required for the medical service and then the medical good. Why? Because like using the predictive analytics, you can find out like what is the like next growth rate of the cancer tumors, or like what is the health rate with which it may going to proceed in deteriorative fashion or in the like improvement fashion, right? So like and also another challenge that do exist with this data is the data need not be like present in your premise. That can be even in the off-center, off-premise data center. Like for example, your sensitive information may be there in some other countries' data storage. That is one aspect. And also, like when you are having analytics providers, these analytics providers need not be the cloud service owners. In the sense, like you're having a cloud service from some vendor, and the challenge is that like they don't have the analytics service. So your data may be outsourced to someone else. In that case, how it can be taken care, that also need to be understood. So, like the challenge here is the concern is of the privacy, because we are not like comfortable in sharing our information with the outsiders. That is first thing. Wherein like they can identify who are the actual users and get back to us. See, even though data anonymization people talk about, but that is not a foolproof technique that can provide. So, but at the same time, yeah, just a minute.
Pavan is rejoining in 2 minutes, sir. There is some network system issue, I think he got. Yes, please wait for 2 minutes. I hope I am audible, right? Thank you, Jyoti ma'am. Thank you, Sangeeta ma'am. Yeah, so Pavan has some system issue. He is will be joining soon. Pavan is rejoining some system issue. Pavan, you are muted.
Yeah, now I think I am audible.
Yes.
Yeah, I think. Sorry, there was some connection issue or something. I don't know. Like it suddenly stopped working. Stopped working. Probably we don't have the Cisco switches or routers, so maybe it is taking revenge on this talk by the Cisco. Yeah, okay, it was that, just a joking part. So, like, okay, to start with, just I will share the screen. Yeah, I was talking about like how this data that is stored at our premise or off premise can lead to a lot of challenges with our smart machines or whatever. Now, imagine a situation we are having a smart coffee vending machine, like that can also lead to one sort of another one or the other sort of the problem. Like if you're having a smart coffee or a tea vending machine, like it can make a note of how much tea or coffee is consumed at your house. Like vending machine will not be there, but just think that like it is a coffee preparation machine or a coffee or a tea preparing machine. So it can give you the consumption, like what is your consumption per day. So like based on that, if something can be planned against you, or like it can be like can be a disaster thing, like if something can be planned out of it or that data, then if someone can plan like what is your entire consumption, and then like what can be added to it and what cannot be added to it, that is fine. Like if someone can take the data and provide a predictive model and then give a good feedback to you, that is okay, that is even acceptable. But at the same time, if it is for your disaster or something, like it will be a problematic thing. So but always we believe in prevention is better than cure. So we will have to devise some mechanisms such that like whatever the data that has been there, that is like properly stored, and then like we can provide some platform so that even people can do analytics over that and give a good feedback to us. That is what we do expect in the data analytics part. Hope the slide number 4 is visible.
Yeah.
Yeah, okay. So thanks for confirming. So now, like having said that, like now how we will provide this security or any other aspect in this case. Now, if the data is like if it is in plain format, then others can also like access it, or even the cloud can access it. That is one of the challenges which I was mentioning earlier. Now, one of the possible solution for that is like to make the server not to learn anything from the data, or even from other users not to access your data, then you can encrypt the data and keep it onto the cloud or the standalone server. But the challenge doesn't, or the like the challenge doesn't end over there. Now, if you're keeping the encrypted data over the cloud, but if you want to do some modification over the data, or if you want to take out something, or if you want to add something to the data, what you will do? See, one of the solutions what you can do is download the data and then do the modifications after decrypting, and then again encrypt it and put it onto the cloud. Even though it looks somewhat simple, and also the solution is okay, that satisfy the requirements, but the challenge is not there. The challenge is that like if the data is huge, like every time you have to download and upload 3 to 4 GB of data, then you can imagine if you do some changes per day, like 2 to 3, then you have to do so many downloads and uploads, which no one would like to do. That is one thing. Now, even in the case of the plain text, if you keep, and if you want to make the server not to learn anything from the data, then like there is something called as an oblivious transfer mechanism, wherein the server will not learn anything from like your behavior. Like in the sense, now you are accessing Netflix or Amazon Prime for the videos. Now, if the Amazon or the Netflix can make a behavioral pattern out of your data, they can recommend you more data similar to that content. But at the same time, you see, that is for the good. Okay, like what you are interested, they are recommending. But on the other side of the coin, if that data is being provided to someone else, they can come to sell you some products, right? This is the biggest question we do have, whether the Gmail employees can are able to read our emails. That we don't have a proper answer from anyone till now. Like, but it is assumed that like they will not be having the access to that. That is what we assume. Okay, now this is useful if you use the Oblivious transfer. The thing with this Oblivious transfer is it provides the complete privacy, because we are not doing any computation over the cloud. Whatever is required, we are downloading, we are doing the operation, and again we are uploading onto the cloud. So the cloud is also not understanding what is there in our data, and also it is like a memoryless protocol we can call, and also none of the users in the cloud can also collude together and then do any sort of an attack over the data, because it is in the encrypted format and even nobody knows what exactly there. So learning is not possible. But we want learning to happen. Why? Because it is also having a good part, that is like you can get an analytics and then you can do the predictive analytics, wherein we can get some good feedback out of this. So as I told, one possible solution to this is to encrypt the data and store it, but the encryption comes with a limit. So the limit is the data, if it is there in the encrypted format, then the keys also need to be shared if the data has to be outsourced for some computation over the data. That is one thing. Like now, as I told you before, if the cloud service provider is not having the analytics service, then the data which is there on your cloud has to be accessed by someone from the someone not from that cloud organization, right? So that time that person should also have the access permission to this data. That is the challenge. And also, like when you are having this data in the encrypted format, even a simple searching operation over the encrypted database requires lot of computational overhead. Lot of computational overhead in the sense like it will produces a lot of noise when you perform this computation over the encrypted data. So we need to make sure that such noise is reduced, and then we will get the results at the simplest possible thing. And also the simple statistical analysis becomes impossible with standard methods of the encryption. Why? Because like if the data is in encrypted format, we don't know which algorithm to run there. We don't know any idea of the data or how it looks like to make out any patterns that are visible to eyes or for a simple test and then run it because the data is in encrypted format, right? See, these kind of computational tasks are often crucial to the business, but at the same time, like it should make sure that the data or the sensitive information is not revealed. Or in general, we can say that business is not need not be only in the economical matters. Like in overall perspective, the business needs insight. At the same time, the data should not be revealed. That's what the challenge is. Now coming to the question, can homomorphic encryption scheme be a solution for this problem? Right, see, homomorphic encryption scheme is in that, like just for an overview, homomorphic encryption scheme allows computations over the encrypted data without decrypting it. That means like the data which we are using, which we will store it at some server, like which can be in the standalone in-premise server or off-premise server or even a cloud, the data we can perform the computation over the encrypted data without decrypting it. But the biggest challenge in this approach is data will be in the encrypted form that has not been able, that will not be in a position to be read by the normal human beings or even by some of the algorithms because that will be in the encrypted format. Now, how homomorphic encryption has been performed or how it has been done is like it is done over an algebraic structure ring, which we will see it at a later point of time. This algebraic structure ring, like it is similar to any other algebraic structure. Like if it's a set of elements that satisfy some properties, then we call it as a group or a like an vector space or whatever, like an higher algebraic structure. Now that is one part of the story, whether we can do this encryption, decryption, and then can we compute over the encrypted data. But the next question is, once you do the computation, where the data need to be decrypted, whether it has to be decrypted in the cloud itself or it has to be downloaded into the end device and then decrypted. See, the first challenge is if we decrypt that data in the cloud itself, then there is no meaning of having encryption and then decrypting it at the cloud. Why? Because the cloud will come to know what is the content of the data if we decrypt at the cloud itself. So the alternative solution is download it to the end device and then do the computation. But here also comes a challenge because the end devices that are the mobile device or a thin client, they will have the limitations of the computation power. Whether will they be able to like have some running some decryption algorithms so that they can understand or decrypt the data. That is the challenge. So one thing what we can make is, so using private keys of the end users at the device after downloading, if we can decrypt it, that would be a solution. We will talk to it at a later that like if we can encrypt the data and store it onto the cloud and do the computation over the encrypted data, and then like whatever the analytics is there, whether you are outsourcing it or doing it on the cloud, that is also is fine. Then don't decrypt it at the cloud, but decrypt it to the end device, and using the end device's private keys, if you can able to decrypt that data, that can be one of the foolproof technique. So homomorphic encryption scheme provides one such techniques wherein you can do the computation over the encrypted data. Now, that is one aspect, and now it is data sets available for the research. Now, as you know, the large amount of data is available from different patients relevant to a particular disease are readily available, but the privacy matters over there. So, if you take some of the publicly available data sets, that comes with a challenge, that is, it will have the greatest access to the data and the steepest privacy challenge will be there. So one of the possible solutions to have the data sets is to have a privately compiled data sets that is in collaboration with the patients to outsource the data, and also like hospitals and clinics through an agreement with the companies. So one of the possible solutions for the problem which I was talking till now is homomorphic encryption, and then use the machine learning algorithms over this encrypted data and perform the analytics over such data, and then get the result also in the encrypted format. Now here the question, like whether the data is outsourced or data is stored or whatever, data is in the encrypted format, then we are not bothered like what we are going to do with it. So if you take a logistic regression model wherein the predictive equation to screen diabetes can be like if it is given in this format, whereas p of x is given as e power x by e power x minus 1 with parameters given as follows, that x will take the values minus 10.0382 plus 0.33 a and random glucose sugar, random plasma glucose, or postprandial time in hours, or all these parameters will contribute to this equation. So if this equation can be done in a plain text format, it is quite easy to compute it, because we know like if you take this exponential function and if you compute it, you will get the values. But the challenge comes when you want to do it in an encrypted format. Assume that this is also in an encrypted text. Then, like, how do you perform the analytics over such data taking these parameters? That becomes a quite challenging task. So homomorphic encryption scheme is one such techniques, as I told you, which allows the computation over the encrypted data. But that comes with a challenge that this homomorphic encryption scheme produces a lot of noise during the computation. So reducing this noise is one of the challenges. And homomorphic addition and homomorphic multiplication are the only possible operations that can be performed over the encrypted data, and no other operations are performed, right? And also, like in the year 2009, there are the fully homomorphic encryption scheme was proposed as a cryptographic flavor of it, but it is having a lot of applications in present day world where privacy and then privacy preserving computation matters a lot. Now, this addition and multiplication of bits corresponds to bitwise XOR and operation, and it allows the evaluation of the Boolean circuits. And the most efficient fully homomorphic encryption schemes works with the algebraic structure ring. As I told you, like there are different algebraic structures are there, but this fully homomorphic encryption schemes, one of them that can be easily implementable and also like which works efficiently is defined over the algebraic structure ring. So in the case of the fully homomorphic encryption schemes, this ring is defined something like this. Okay, there is a notational abuse over here, like it should be a capital R, but with not with this symbol, it looks like a real number. Sorry for that, the typo is there. So this ring is constructed such that it will contain the elements from the integers. This usage is correct because we are representing the integers over here. Like this ring is constructed such that over the integers, such that the highest power of the elements that are there in this ring will be having a value lesser than x power n plus 1. And this n is being the power of 2. The objects in this scheme are all of polynomials with integer coefficients of degree less than n. So like this is like a modulo operation. How do we perform? If you are having this value like modulo 5, then whatever the elements that are possible are having a value lesser than 5. So similar operation is used here, that this ring, particular ring, will have the elements of integers such that that are having a power less than x power n plus 1, where n is a power of 2. This is how this ring is constructed, and then like this is constructed mainly to get some optimal result. And the plain text and ciphertext are such polynomials, they are having some powers that has been restricted. Now an element that belongs to the ring will be of this form, wherein sigma is equal to 0 to n minus 1. Sigma is spanning, that means these elements can take the values, and then ai and xi, where ai belongs to the integer. So any element that is whether a plain text or ciphertext will be of this format. And computing on the elements of the ring means that we multiply or add with the elements that corresponds to this ring with this restriction, that is modulo x power n plus 1. That means all the elements will be within this range. Now, the key generation and encryption functions make use of the probability distributions that are chi key and chi-er on the ring. And chi key from the ring, it is a uniform distribution. It will follow on polynomials with coefficients -1, 0, and 1. And chi-er is a discrete Gaussian distribution used to sample small noise or the error polynomials. As we give this fully homomorphic encryption, similar to any other a set of cryptographic algorithms, this fully homomorphic encryption set of algorithms is given by 5 algorithms. But whereas in the case of the other algorithms, we will also give them in the form of a key generation algorithm or a system setup and an encryption algorithm, decryption algorithm. But here in our case of the fully homomorphic encryption scheme, we require 5 set of algorithms to implement the same. So in the case of the key generation algorithm, like it is, you can even think of it as a system setup which will work in a for longer time. That means that can be like that we are constructing that with the assumption that the thing is implementable in the polynomial time algorithm. That is a basic what is the assumption we do make while setting up any cryptographic algorithm. And then a key generation algorithm is given something like this as for the system parameters, like with n, q, t, chi k, and chi-r, and that generates a set of public and private key pair and an evaluation key. And this evaluation key plays an important role in the homomorphic multiplication and private key in the encrypted format. So on the input degree n, moduli q and t, the key generation algorithm samples this small polynomials f dash, and a chi key will f will take the value chi key from the key distribution, and it will set the f as tf dash plus 1 with the base q. This f dash is sorry, if this f is not invertible for some reason, then this f dash will be chosen, a new f dash will be chosen such that this f is invertible, because that is where the one of the key what is the aspects of this algorithm lies, wherein it helps in the encryption and decryption. It computes the value of h such that pg f inverse with q, where f inverse also belongs to the ring, is the inverse of the f modulo q, and it outputs the public and the private key here, where the public key is given by h and the secret key is given by f, and that also belongs to the ring with an evaluation key with satisfy this criteria, and this has been used in the homomorphic multiplication algorithm. Now coming to the homomorphic encryption algorithm, see, just remember like any algorithm, it's similar to that. This homomorphic encryption algorithm also works, but with some different parameters. One thing is it will take the plain text as a message, and then it will take the public key, but it will produce a ciphertext. So if you see this encryption algorithm, it samples the smaller polynomials and output the ciphertext using the public key. That means like the message text, whatever is there in the plain format, will be operated with the public key in the presence of other system parameters, and it produces a ciphertext that also belongs to the ring. So similarly, the decryption algorithm can be given something like this. In the case of the decryption algorithm, the algorithm, like it is also unlike any other decryption algorithm. It takes a ciphertext and then a private key and produces the decryption algorithm to compute the plain text message. So you can have the what is a ciphertext, and then you will take the keys, and that is the key is given over here as f. So on the ciphertext, you will operate with the private key or the secret key, and then you will try to get back the original message that also belongs to the ring. Now, like homomorphic addition is simple. Like if you are having two ciphertext, if you add them with the condition that is under the within the range of the modulo addition, then we will get the result. So homomorphic addition is not that difficult, because if you are having two ciphertext, adding them will produce another ciphertext that will be similar to the plain text. That means if you perform any operation the plain text, then that will also correspond to the addition operation also in the ciphertext domain also. But homomorphic multiplication is somewhat different. In this case, if given two ciphertexts C1 and C2, and then the evaluation key like to compute, then we can compute this multiplication something this with the help of the key switch. Key switch is required. Like key switch will help us in addition to the ciphertext to get the result what is there in the multiplication. Like it is mainly needed to transform the ciphertext so that it can be decrypted with the original secret key. So if you see two ciphertext, then like if you take this from the system parameters, then even you can compute this operation. Now, whatever I have told till now can be summarized with this diagram. Like assume that the data is stored on this cloud. Like in this paper, they had taken the example of Windows Azure, so I have preserved the same. Like now, if you observe this figure, what you can understand is like the medical data is there that will be encrypted with the personal password, or you can think it as an secret key, and the encrypted data is stored onto the cloud so that this data is not accessible to anyone else, because even if that is accessible, that is in the ciphertext mode, and the cloud can run any analytics over this encrypted data and then get the results also in the encrypted format. Now this cloud will return the encrypted prediction data, and then the end user can download it, and then with the personal can download it and decrypt it with the personal password. So if you observe this diagram in the proposed method, the data will be in the plain text only at the owner's place, and then it will be in the encrypted format as soon as it leaves your premise. Like whether the data is in motion or if the data is in rest, in both the aspects, the data will be in the encrypted format. So no one can learn what is there in the data, like since the data is in ciphertext. But having said that, but if the data is in the ciphertext, we are using the fully homomorphic encryption scheme, and then we can perform some limited operation on that data so that the privacy of that data is been preserved. So anywhere in this diagram, except for the point 1 and 6, the data will be in the ciphertext format and not in the plain text format that we can understand from this diagram. So we can say that this is the privacy preserving computation wherein the data is in the encrypted format on the cloud, and we are running some algorithms over there, and we can perform some computation, and we can get the results. That results can be also in the encrypted format that we can download, and then we can get it. And also the challenge here is that, as I mentioned, if the end device is a mobile or if it is a thin client, then downloading it, whether the computation is required or the computation power of these devices are sufficient or not, that is a challenge that need to be explored. We need to select this ring and other algebraic structures and the associated hardware or whatever the mechanism with suitability that can even operate on a ordinary smartphones with what is a permissible amount of data, like with permissible amount of computation power. This is what we can assure, and we can do it. So we can see that at any point the data privacy has not been compromised in the data at rest position. This is what one part of the talk that forms the privacy preserving computation. And like what can be drawn as a conclusion from this part is even we can do the predictive analytics over the encrypted data, and also it provides an additional layer of security or a privacy, like to the data stored in any sort of data center, whether it can be on premise or like boundary constraints are there or whatever. So we can do it. And some of the strategies that do exist in these aspects are we can develop better strategies for the encryption and decryption with lesser computational overhead over the algebraic structure. So in this case, ring is used. Can we use group, or why can't we use group? All these problems need to be addressed or understood from the different perspective, not only from the cryptographic perspective, also from the implementable part of the computation. Also, we need to check. That is the this part of the talk that leads to privacy preserving computation. Now, coming to the aspect of the communication, these are some of the references that are used for preparing this talk. I will share with the organizers, and you can use that one. Now, coming to the second part of the talk, like We have seen the privacy preserving computation, how we can perform. But here, the challenge here is like if the data is in motion, if the data is not in the encrypted format, because always it is not possible. Okay. In the case of the, 1 minute. Okay. In the case of the privacy preserving computation, it is fine. Like we can have the encrypted data and store it onto the, get it stored on the cloud and do this all these operations. But suppose if we are not able to do that, that means like we cannot afford or we cannot go for this kind of a solution wherein our end devices are not that sufficiently capable to generate some sort of an computation. Then even then we can try to provide the privacy to some extent, but not a fully homomorphic encryption type of a thing. But at least we can make sure that this will not happen when the data is in motion. So for that, like various cryptographic algorithms and then the cyber security techniques are there for this communication, and also like network wise also it is there. But we will try to emphasize on some of the aspects that can be incorporated so that privacy preserving communication is also possible, that we will see in this part of the talk. And this data breaches can happen for many reasons, and one of the reasons for that is the poor coding skills one is having. This poor coding skills, in the sense, these poor coding practices that developers use, that makes it easy for the attackers to attack the system and make it compromised. So when a software is designed, like it is not, if it is not designed with security aspect in mind, then what anyone can do is they can develop some software, or they can develop some piece of code or a tool they can use. Then they can point it to these data stores, and then they can download anything from that data centers. So now these secure coding practices can range anywhere from high-level principles to detailed code analysis. And also every program language has its own nuances and then techniques to code securely within its environment. So I don't go and say that, like, see, if you use the Windows operating system, this is good, or Linux operating system, this is good. But I will give as general, like what are the nuances that do exist in the programming languages, and that is independent of the operating system and also independent of the programming language, because I cannot say that with C this is good, Python this is not good, and all those things. Like what are in general that can be followed so that it will be useful as a privacy preserving aspect. Now coming to this, like we can talk all this aspect as a secure coding in some way. That is secure coding. It also refers to as secure programming. It involves writing code in high-level programming language that follows the strict principles with the goal of preventing potential vulnerabilities. And it involves secure development environment that is built on a reliable and secure IT infrastructure using secure hardware, software, and services. See, if you develop this software very well with the privacy and security aspects in mind, if the hardware itself is not reliable, then what we can do, right? The hardware on its own, if it is having some malware on it, or like if it is having some inherent error or an inherent adversary in it, like we cannot do anything. So everything should go hand in hand. It's like a triangle. That is like a hardware. Over a secured hardware, we should develop a software by following the principles of the software engineering, secure software engineering, and then build services on top of it so that we can get good, what is a privacy preserving communication as well. So these challenges are becoming more and more important. Why? Because more and more transactions are also moving onto the cloud, and these security incidents often originate deep in the applications underlying software development, and it can have serious consequences for business and as well as for the individuals. And this insecure code is important even in industries. Why? Because like if you are in the industries such as finance, healthcare, energy, and transport, because it can lead to huge financial and property damages and market manipulation, theft, and even the physical harm and fatalities. Like for example, if you take like finance, like if your data is there stored at some position, and then like it has been like if the bits are flipped at one of the positions and at the most significant bit, then you can imagine like what kind of panicness this can create. These are only some of the challenges that do exist in even in this space. Now coming to the other aspect, Now coming to the other aspect, like what do that exist in this secure coding, and then like what are the things that do exist in this is the access control, and then like keep it secure and simple. Some of the principles which we can follow, and then the risk analysis, automate, and then the right cryptography. Access control, which you may be familiar with. Access control in the sense like what you are access to or what you should not have access to will give the access control, and keeping it secure and simple is another aspect that need to be understood in this case that we will see. And this access control is like deciding or control what end user can do and cannot do while designing or developing application. See, whenever there is some application, many of the users, not many, even most of the users will try to complete the task what the software can do it. But some try to see if they can break the application, or some will find a like some to see like is there any vulnerabilities that do exist in the application. But a very few people will find a way to break it. And this application takes the data by the end user, irrespective of whether it is a code or a data. Like even though this application like access control problem and this whether an application taking in code irrespective of data is to some extent it is prohibited because of the validation we do at the input level to the application, but still it is a challenge. And then such kind of challenge we can call it as injection attacks, which are even finding a place till today in the list of top 10 vulnerabilities provided by the list that is called as OWASP list. Like there is a foundation called as OWASP, or also called as OWASP, that is the Open Web Application Security Project, that lists every year the set of vulnerabilities that do exist in this space. And injection attack is one among that over the years. Yeah, coming to the access control point, like access control is fine with the help of the rules and the regulation which we can provide, but addition to that, we should have some additional things. Then only we can have a for system that is like foolproof, right? That some of the vulnerabilities that do exist as a consequence in this access control are the injection, and then XML external entities, cross-site scripting, and insecure deserialization. See, even though they're like these names are maybe new to us or not familiar to us, but we may be a victim of all these kind of attacks in one or the other time that we will see it over here. Now, these injection attacks are one of the oldest attacks, as I told, and they're amongst the oldest attacks aimed at the web application, and they can lead to data theft, data loss, or loss of data integrity, and denial of service, as well as full system compromise. In this case, an attacker will supply an untrusted input to a program, and this input gets processed by an interpreter as a part of a command or a query. But nowadays, many people are using Google Form for their work, and that Google form will take the do the input validation, and it will take only the data as input as a plain text, and then it will save it in the Excel sheet or wherever it is intended to, but it will not launch an attack. And also that Google Forms provides an facility to do the input validation, wherein like we can find out if there are any special character, if there is a comment line and all, and we can find out if there is any possible vulnerabilities that do exist in the input provided by the user. Now, SQL injection is one of the important and then used important technique that have been used, and wherein an attacker executes a malicious payload that control a web application database server. And impacts of this SQL injections are authentication bypass, information disclosure, data loss, data theft, and also data integrity loss. Now, coming to the example SQL statement, like when you have an SQL statement, it will be something like this. So select star from users where user ID is 105. When you run this structured query language in DBMS, so it will retrieve the details of a user with user ID 105 from the table users. But the challenge here is like, okay, this is good that it is retrieving all the details like credit card, debit card, or whatever from the user ID 105. But if an attacker or if an what do you say, if someone who is having knowledge of this SQL can add a bit more of this query language, and then he can make the system to compromise. So this kind of a statement is an injection attack which runs with the simple logic, wherein like if you use an OR gate or if you know the OR table or truth value table, what it will do, if one of the inputs are true, then the output will be true. So the structured query language will work in that part, like it will select all the fields from the table users where this condition is satisfied. When OR is used, then either this part can satisfy or this part can satisfy. Assume that this part will be always been satisfied because 1 is equal to 1. So in respect, so just instead of retrieving the user ID, the details of the user ID with the user ID 105, this query will retrieve all the details of the users from the table users. So this is what one of the challenges that do exist in this case in the SQL injection attack. So there are various methods that have been proposed, like to mitigate the users in doing this kind of an attack, and machine learning, deep learning, and also some sort of artificial intelligence also been used to make sure that people are not being victims of these kind of injection attacks, and then those injection attacks are mitigated. Now coming to the cross-site scripting attack, in this case the attacker aims to execute the malicious scripts in a web browser of the victim by including malicious code in the legitimate web page or web application. Here there will be no error from the end user, but if the end user try to access one of the web pages, then if it is been changed, right? So see, like now if I'm accessing Gmail, if I'm redirected to something else without my mistake, what is my mistake, right? But large companies will take care that such errors will not happen. But the thing is, like when we are having the vulnerable vehicles, such as these chatbots or web pages that allow comments, then people can post some links that look similar to the original ones, but they're not with the case. So this cross-site scripting is also one of such attacks. Now coming to the code injection attack, the attacker injects the application code written in the application language, and this can be used to execute operating system commands with the privileges of the user who is running the web application. And in the advanced cases, the attacker may exploit the additional privilege escalation vulnerabilities, and which may lead to the full web server compromise. Also, this is also similar to the injection attack, but it is done at the code level, not at the database level. Now coming to the CRLF injection attack, in this case the attacker injects an unexpected CRLF character sequence, that is the carriage written in the line feed, and this sequence is used to split an HTTP response header and write some arbitrary content to the response body. So this attack can also be combined with the cross-site scripting, which we have seen now. There are two types of that is, one is log poisoning and then the HTTP response splitting. In the case of the log poisoning, the attacker falsifies the log file entries by inserting an end of a line and an extra line he can do it. But in the case of the HTTP response splitting, whenever a sender sends a request to a server or a client sends a request to a server, the response will come from the server in the form of a HTTP response, we can call it. If the attacker can modify that HTTP response, then he can launch an attack. Like what he will do is the attacker will try to like decipher the HTTP response, and then he will make sure that the field content length is made as 0. So this will cause the web browser to treat this as a terminated response and begin parsing a new response. So when a fake HTTP response is added with HTTP 1.1 200 OK, then the compiler, which is compiling, that means the browser, which is reading this response, will understand, and then it will parse the content, thinking that okay, the response is received from the original server, and it is thinking that the content length is 25. So this will make the response reader, that is the web browser, to read the next 25 bytes, which can even have the script that has been targeted. That is the cross-site scripting attack can be there. So this is how this response attack has also been launched. And this email header injection attack is also similar to the CRLF injection attack. The attacker sends the IMAP or SMTP commands to a mail server that is not directly available via a web application. And this malicious user may be able to introduce additional headers into the message, thereby instructing the mail server to behave differently than the intended one. Next, coming to the host header attack, the attacker abuses the implicit trust of the HTTP host header to poison the password reset functionalities and then the web caches. And you know, like these are some of the important ones like web cache poisoning and password reset poisoning. Web cache poisoning is an important one. Why? Because web caches will help us in taking us to the web pages which we are visiting it frequently. But if these web caches have been poisoned, like there are various ways to find out whether these web caches are poisoned. But like how do you make sure that they are not poisoned? If you are visiting some page regularly, then there are chances that these web caches are poisoned with some other links. So whenever you try to access that, then you may be redirected to something else. For example, if you are having DNS resolution, like like whatever we use for the address resolution, the DNS, it works in a similar manner wherein the caches will have a table wherein this frequently accessed pages will be there. That is the mapping from name server to the IP addresses will be there. If that has been changed, then you are redirected to something else. Then you can imagine like what kind of attacks this can launch on by showing you a similar web page. And password reset poisoning is we are always familiar with. Sometimes we get a link without our what to say involvement to reset some of the links. Similarly, this lightweight directory access protocol is also subjected to similar kind of an attack. Like we use this directory services mainly to make sure that we access these services faster. Like for example, the certifications at the transport layer or any layer, we use the directory services for getting that services because accessing a directory is quite easy than invoking an application. Why? Because if you are running an X.500 kind of a directory service, we can directly go to that page and you can access it. Like it's similar to searching a telephone directory, wherein it has names sorted in an order. If you want to search something starting with C, then you can directly go to C and you can start that instead of starting with A sequentially. Right? So directory services will provide such service wherein you can directly go to the X500 services and then you can start accessing it. And when an attacker is able to modify the LDAP statement, that is the lightweight directory access protocol statement, the process will run with the same permission as the component that executed the command, and this can cause a serious security problems where the permission grants the right to query, modify, or remove anything inside a LDAP tree. Now, coming to the OS command injection attack, like till now, we have seen the SQL injection attack that will inject an SQL command maliciously into the database. But in the case of the OS command injection, what the payload will do is the attack, the attacker will try to insert something to the OS executing commands, right? Like some commands like shutdown and all will have importance with respect to a OS, that is the operating system. So, like when you are developing such kind of a thing, it is always important to make sure that OS commands are not accessible to the application developers. So there may be some vulnerability the attackers can use, and they can even make the system to compromise by poisoning the OS itself. And then next, coming to the Xpath injection attack in XML databases. These XML tags are mainly used to create our own customized tags to store the data. Like if the Xpath is and also Xpath is a query language that is used for selecting nodes from an XML document. Now, if something is changed and if something can be manipulated similar to the directory access protocol, then also we can have some of the challenges and then the system will compromise. And this insecure deserialization is a vulnerability which occurs when untrusted data is used to abuse the logic of an application. There is no like a single way to do that. Like there are various ways that can be used, and even it can be used with other cross-site scripting and other applications wherein a denial of service can be familiar with that and also be part of. Right now, coming to the keeping it simple and then secure, like these are some of the attacks that are there. But now, how we can make sure that we are like if you are using this in an industrial setup, like what are the measures we can take so that all these vulnerabilities can also be addressed. So one of the ways is to keep the design simple so that the additional security can be added as and when required rather than on a complex design. And also complex architectures are always harder to understand and difficult to debug. So what one can do is like they can have a network, they can have a network of people instead of having a single person who can manage the network topology or network architecture of a company, so that even if one leaves, the other will be there to take care. But always, to the extent possible, try to avoid the complex architectures and try to have something that are built independently, so that if something goes wrong, then also we can use the other one. So okay, that is fine, but still it also comes with a cost that we need to decide whether we are compromising on the privacy or on the cost. See, every time we cannot compromise on the cost, and also at the same time we cannot compromise every the time on the privacy. So that balance we need to make in taking the decisions. So that's why like simple, well-designed code with extensive comment is easier to review and less prone to programming errors. But at the same time, this is easier than the complicated garbage. But the problem is with the economy. Like if we go on writing the good code with hiring good level of programmers and other things, the challenge will be with the economy, like how much money we will be spending in keeping these services up. The configuration management tools allows for all the systems of a single type to have the same configuration, and it will can simplify the user experience. But that too comes with a challenge. So we need to figure out what is our requirement, keeping in the budget. So we need to make a balance and we need to move forward. Coming to the risk analysis or the threat modeling, this risk analysis or threat modeling is like practicing or examining a software design to find places where these attackers can compromise it. So it is always better to document such things and keep it as an evolving document. Why? Because like whatever considered as safe today may not be safe for tomorrow. So that's why it is always better to find the threats against the application by following the flow of data and identifying the places of weakness to certain exploits, so that we can find out if there are any threats, they are addressed and then they are mitigated, and then we can rate them according to the what are the industry operational manuals or the standards are there. We can rate these threats and then we can find out a solution for that. So risk analysis is like a continuous process. We need to validate and then again we need to go for higher level certifications and then we can validate. It's like a game. Like every time you propose new thing, someone will attack that and then they come up with a newer one. It's like a game that should be played by the developer and then the attacker. Now, cryptography is also plays a major role over here. So never store the entire cryptographic keys in the same place as its data encrypt. Like as I told in the previous case, one of the possible solution to make sure that the cloud will not have access to the data, like we can encrypt it and keep it onto the cloud. But at the same time, if you are trying to do that, in that case, like we should not store the cryptographic keys in the same place as the cloud which is there, because it can lead to data compromise and then the users can collude and get back the data. And also don't hard code the cryptographic keys in the code, and also don't be under the impression that whatever algorithm you are going to create will having a very good cryptographic standards and it can withstand the attacks. Never use the broken algorithms. Do not use the good known existing frameworks provided by the organizations like AES 256, Argon, or PBKDF2, and also like do encrypt the data that is both at rest and also in the transit. And automating the task is also an important aspect with this case. That is, if you keep the autopilot mode, it will reduce the human error, and then we can automate the process. Like automating will help in one way, every time an instance is created, like for example, for an operating system, like now we are creating a Linux or creating an Windows. So when you are trying to develop it from scratch, then there are chances that you may forget to add some of the security requirement or even for any other perspective. So it is always better to replicate it instead of just developing from the scratch, and also like adopt and develop technologies to understand and mitigate abnormal acts that are insider or the outsider attack. So now what are the measures to include in the secure coding? What we can think in generally is code minification and obfuscation technique, so that our code will look like a garbage to the attacker to access, and also having some garbage kind of a thing, so that they can deter the potential attackers. And we need to do the regular code reviews, wherein if any patch of data that has been exploited, or if any cryptographic way if it is exploited, what we can do it. And also avoiding shortcuts is another way. It can be tempting to for the developers to take the shortcuts, but at the same time, like it is having the serious security implications. See, like avoiding shortcuts in the sense, developers use the shortcuts only to make sure that the releases are faster, but it can lead to other sort of problem. And also it is important to avoid the components with the known vulnerabilities. Like as I told you before, like if you know something and if you have developed something on your own, then you should not be under the impression that it is a secure. There may be cases that it can even be broken. And like auditing and logging is a continuous process that we need to do so that our systems will not be compromised. Now, coming to this aspect, like in this video, I will just share it with the participant. I will not run it. Like in this, we will show how this data, like been stored. Like some scripts can be triggered, right? So without our knowledge, how our systems can be communicating with the other systems or the hackers. So what can be done is like you can check that by using the vulnerability testing or the penetration testing. Like in this video, I have provided with the penetration testing demo, wherein you can like write some script wherein launch a payload, and if some machine tries to like download that script, then it will become a victim. It will create a reverse TCP connection, and someone can easily control your system sitting remotely without your knowledge. So there are various machine learning techniques that are developed for mitigating such sort of things that you can see for. So in this video, what I have made is like we have taken the example of the Kali Linux and then in Windows 10 machine. So from Windows 10 machine, we will, sorry, from the Kali Linux, we will access the Windows machine, and without the knowledge of the Windows machine, we will try to take what is happening or try to learn what is happening in the Windows machine. That we will see shortly. I will show you briefly within a minute, like how it has been done. Just give me a minute. It load. So wherein like a payload will be created, and then like that payload will be launched at the target machine, and that target machine will create an reverse TCP connection, and our system will be compromised in this case. That we will see how it has been done. So just a minute, just let it load. So we can just see in this case, without the knowledge of the without our knowledge, even our systems can communicate with someone. Yeah, okay, like I will share this with the participant. You can just launch this, and then you can see what is wrong in the present thing, so that we can even find out those like reverse TCP connections, and we can remove them. That we can do it. Okay. Yeah, that's all I planned for this presentation. So if you have any doubts, please do ask me. If I know the answer, we will try to discuss. So for concluding, like we can develop better strategies for having privacy preserving computation and then communication in general. Okay, so we have seen various techniques that do exist in the literature for the computation and then the communication. Like we can come up with new techniques wherein we can use them, and then like we can come up with results so that we will not be the victims of something. Okay, so with this, I would like to take the questions if there are any from the participants.
So participants are requested to ask some questions if you have any to the speaker. I think there are no queries for you, Pavan. Yeah. If there are no further queries, let us thank the first person, Dr. Pavan Kumar, for giving some outlook on the security aspects and how you can link the security aspects to the data science. Pavan, I have one small doubt. The notation you used in the first presentation. Can you hear me, Pavan? Pavan, can you hear me? If there are no further queries, I think he got disconnected. Um, yeah, Pavan, I have one basic simple doubt. In the first presentation, can you hear me, Pavan? You are muted, I think.
Yes, sir. Yeah.
In the first presentation,
Yeah.
when you are discussing some challenges and all, computational complexity you have put, right?
Yeah.
There you have the big O of small o of n plus 2 log n. Why that specifically that two terms been given? Any specific reason behind that?
No specific reason, like it will have two challenges there. One is the communication complexity and another is the computation complexity. So both of them are been added in, are shown in that format.
Oh, together you have put, okay.
Right. Both communication and computation are taking place in that case. Like when we are downloading it and then like when you are performing the,
Yeah, I understood. Two different
yeah.
tasks, and so you're given. Okay. I thought that is completely computational complexity. So I
Hmm.
thought why it is big O of again.
Yeah, yeah, right. I understand.
But another aspect, if the data nowadays, particularly when it comes to data science, real data is very rarely you will get, and means in the sense if whatever we get for the experimentation purpose, what we have it in different websites or in different repositories like the Kaggle. They're all real-time data sets only, but it has been even for the public for the exploring and doing analytics on a different dimensions based on how each and every researcher will look at that particular data in his own dimension, panoramic perception. Okay, so when such data, when you are going to, when we develop some models and look for some sort of a pattern finding or any sort of representation learning, we do tasks like this type of problems over the data. Where do the security point will be exposed there?
In that case, like generally security aspect will not be there. Privacy aspect will plays a major role. Like now, for example, if you're taking the drone data set, like now drone will capture it over various regions. If you're taking in a residential area, so in the residential area, there may be a challenge that they should not take it some places like swimming pool and other things. So if it can capture or like nearby, like there, like if they're in the apartment or in a housing society, there may be people who may be walking around and other things that security will be like their privacy will be compromised in that aspect we can take care. But security wise with this data, like there is nothing much to do, but privacy do matters in these cases. Like if it is airport data, like if we are providing it to the users, then their face will be provided, but we don't know like whether they're the actual like they're the people who are planning for some sort of an activity, or like there are normal passengers that we need to find out. Like facial expression and other things also matters there. So generally the privacy is an important aspect there than the security in such cases.
So how to eradicate that?
No, eradicate in the sense like now one thing is homomorphic encryption scheme, wherein the data will be there in the plain text, but for the person who are doing the analytics, we will provide them my encrypted data so that they can do any operation on the encrypted data by using fully homomorphic encryption or any other technique and give back the encrypted format. So we will again decrypt it and we will get the results of the computation.
If they are using, when you said about airport of for face capturing and all, even it need not be an airport, but even if you are in at your workplace or at your home, or even if you walk around on the road also, because of the advancement in the technology, where cameras are become a part of the mobile, that too with not a single camera but four cameras or five cameras like that. People who are going front but keep the mobile at some place so that they can see what is happening at the back to capture it. And all these things leads to the privacy, right?
Yeah. So yeah, so that's why like all these applications should also have access control mechanisms, like what can access what. Like now cameras are there that can be like that are capturing a particular region. Who can access that camera data? That also we can define at some level. But anyways, like when the human intervention is there, then there is a possibility of the data leakage, and then the privacy compromise is always there.
Yeah.
So we cannot have a completely foolproof wherein only robots will leave. So we need to make sure that day by day we have to come up with new techniques wherein we can have some sort of a technology wherein we can find out. Like for example, drones. Now they are making sure that, like as I told in the lecture also, like we should have the technology with a good hardware, like that is a secure hardware, and software is built on top of it. So there should be an angle from the hardware side also to ensure that like if we are doing it for some application, it should not capture the data fully. Like for example, the drone, when it is doing for an geofencing, like we can provide so that if it flies within that zone, it should not capture the images. It is not possible only with the hardware side. We can sorry, not only possible with the software side. We have to do the hardware side also. Same application for in the camera or any other thing, wherein we have to see like what kind of application where it can use.
So the take-home message for all the participants is, do please check your mobiles. What are all the apps for which your camera data has been given the permission? and what are all the apps for which the contacts list has been given the permission. Because sometimes when we download these things, any app which is maybe the app is required for us, but unknowingly the app while installation will demand us for the camera to access or the contacts to access. And in the verge of being used to use that app, what we do is we give a yes, yes, yes to all, and thereby we land up in some problem. So do please check your mobiles and even systems wherever you are working in at your workplace, or even keep check on the net when you are out for some time. Uh, then you need to uh, we can disconnect your system from the internet. At least you. So these sort of simple things, if one can take, then it will be really helpful, so that not only your data will be your not only your data is secured, even your systems, because of the advancements in the cyber security and all, it is becoming like easy for anyone to access. If you are little bit negligent, or if you are little bit unaware of certain things, then unnecessarily you will end up in some problems.
Yeah, and also like some people have the habit of storing this debit card numbers, account numbers in the contacts that are easily the what is say a place of what is a hackers. Like one of the service providers, application service, they had the provided access. Like they will provide a service like who has called you or whatever that service. One part of their database was hacked. Then you can imagine like all the debit cards and credit card data was hacked. Like that deciphering that message is not difficult, because 16 digits is the card bits, and then like another 3 digits will be CVV and another 4 digits will be expiry date of the card. So if that is available, then people can do anything. So just make sure that we are not the victims of such things. Never store the passwords or even like what is the ATM card numbers or account numbers as part of the contacts, because most of the applications which we use, like they're provided to us free of cost, but what they get in turn for getting this free of cost is our data. That's the reason, like when you're visiting some website or whatever, like some advertisements will come to you, like which you might have recently visited or that are very relevant to you. That is all based on this data access which you have given. See, now you can answer this simple question, like why a service provider or an application service provider on a mobile app, why he require access to our gallery? He can do it on his own, right, without having access to that. So always it is better to use the pure Androids when you are using the mobile phones, instead of having an modified version of the Androids. That is also an important takeaway message.
Yeah, because recently a scholar who is known to me has almost like he has installed some software in his laptop for some research purpose. But apparently, the hackers could able to get control on to his laptop, and then they started demanding so much of a lot of money to because his data is visible for him, but he is not able to access it, he is not able to open it, he is not able to do any sort of work. Despite he possesses the laptop, it is of no use. So they made the laptop to such a situation. So in those cases, what he has done, he could not pay much. So he has lost all the data and purchased a new system. So whenever you are doing such a things, like installing any sort of a software and all, do check multiple times whether it is coming from the proper source or not. Because a simple small changes or one extra character or one small letter, they remove it, we may not pay much attention, but we have to pay a huge amount of loss. Either the data will be lost or you need to lose the money. So all these things, I hope that the participants should remember whenever they do such a things, while accessing the internet, or when they do money transfer and all these things. Please be careful all the times. So with this small note, we'll close the session now. and we'll have the valedictory at 4 o'clock. And after the valediction, I will provide you the link to take the test. So it is a simple Google form, and that contains a few questions. The total around 25 questions you have.
Yeah. Thank you, sir, for the
Yes, Pavan.
invitation for the talk. Yeah. Thank you, sir. See. Thank you all the participants for the patient listeners, patient listening. So, thank you. Have a good day. Bye. So, if you have any doubts or queries, I will share the presentation slides with the sir Chandramodi sir.
The mail I will share that.
You can take it with him, and also if you are looking for any internships for yourself or your students, please write to us. Our faculty members will be happy to get back to you. And also even you can write to Chandramodi sir. Also he takes a lot of intern students working in the area of image processing and video processing. You can contact him, and we can do some good work. Thank you one and all, and good evening.